Hi there everyone, Kevin here. Well, Elrond just launched the new Web Integrated Development Environment, IDE, which is a tool that helps developers to write smart contracts written in Rust programming language and build and deploy them on the Elrond blockchain. This is a web tool, so we don't have to install any prerequisites on our computer. So in this guide, we'll use the Web IDE to write, build, and deploy a smart contract on the Elrond blockchain. We'll revisit one of our previous guides, Build a DApp in 15 minutes, and we'll use the Elrond IDE instead of cloning the smart contract repository, building and deploying it from the command line. Let's get started. First, there was this folder structure we used in our previous guide. We had the ping pong folder. This is the project folder where the magic happens. We have the ping pong wallet. Here we have the PEM file and the wallet owner PEM. We have the contract folder. Here we clone the sample smart contract. We have the ping pong DApp folder, and here we clone the DApp template. We created a wallet, generated a PEM file for that wallet, and saved it in the wallet subfolder. Then we cloned the ping pong smart contract into a contract folder. Then we built it into a WASM file, and then we deployed the WASM file on the Elrond blockchain only using two arguments: the number of XE gold for the ping pong deposit transaction, and the number of seconds the user has to wait until claiming funds. In this guide, we'll use the Elrond Web IDE to manage the smart contract. We will use the same DApp template we used in the previous guide, so everything beside the smart contract is backwards compatible. Okay, so let's access https play.elrond.com and launch the Web IDE. We have a module here where we can either create an empty project or start from a template. For our guide, we'll start with the ping pong smart contract template. So let's just click on ping and pong card. The new project is now loaded, and we can see the library rs file, which is open. The lib.rs file is the main source code of the project and also the starting point. It's written in Rust programming language, a fast and memory efficient language. It's the programming language that we strongly recommend for developing smart contracts on the Elrond blockchain. Apart from lib.rs, we can create other files, of course, but for now, let's just stick to this one file. Here we have identified ping and pong functions and the did user ping and the did get time to pong view functions. It's basically the same code with the one from the ping pong smart contract GitHub repository. Okay, we are ready to compile the smart contract. Let's click the compile button, and after 20 seconds, we'll see the smart contract bytecode in the output pane. This bytecode is the WASM code that will deploy on the Elrond blockchain. We can either copy the WASM code and create a deploy transaction manually directly from our wallet, or we can use the Web IDE to deploy the smart contract. Let's now click on the deploy button. Here we'll see the deploy parameters of the smart contract. We have to set the amount of XE gold that we want to deposit and the number of seconds the users have to wait until they make the Pong transaction, which claims back the same amount. So the first param is the amount. The default is 1 followed by 18 zeros. This means that we'll ping 1 XE gold, and the parameter is the amount of seconds we will set 600. Now let's click on deploy, and after about 10 seconds we'll see the output pane of the details of our contract. The contract address is the one you see now. We can also check it on the Blockchain Explorer and the deploy transaction hash as well. Finally, we can also check on the Blockchain Explorer if the transaction was successful. Now our contract is deployed on the blockchain, and the next step is to clone the sample DApp and to tell the DApp to use our newly deployed smart contract. Basically, the rest of this guide is the same as the previous one. We only showed you how we can make the smart contract development a lot easier, so you don't need a fancy setup and hundreds of dependencies in order to create smart contracts on the Elrond blockchain. Okay, now that we have the smart contract developed, we need to move on to the application layer where we'll be using React.js. So here we'll clone a very simple decentralized app template that implements the calls to our newly deployed smart contract. Make sure we clone the repository in the DApp folder in the parent of ping pong. The web application source code resides in the source folder. We can customize the React.js app using the config.tsx file. Let's copy this sample config.devnet.tsx file into a new file, config.tsx, and let's fill in the smart contract constant with our smart contract address. So if you take a look at line 15, you'll see export contract address equals. Here we'll change our contract address that was shown after we deployed our contract. Once you've changed that, save and close the config.tsx and we'll be ready for our first build. So now it's time to build the app. We'll first install the dependencies with the npm install function. And then we'll start a development server to test our new decentralized app, so we'll run npm run start. If you're running it on your local machine, you'll be able to open up and take a look at what we've done through HTTP localhost port 3000 in your browser. If you start it with your own server, then you can access with HTTP ://IP: port number 3000. The built version only contains static files, so any hosting provider will do. After you start the development server, when you see the sign-in screen, this means the application is up and running. And finally, we're going to want to test our app. We'll get familiar with the Elrond web wallet and Elrond Explorer. Connect with another wallet. Log in with a test wallet. You can reuse your same owner's wallet if you want to, or create a new one. It's up to you. After signing in, we'll see the dashboard where we can see the ping button. Click the ping button and you'll be redirected to the authentication page on the web wallet, Myer wallet, or your authentication device such as Ledger. A new transaction will be created and you'll be asked to confirm. This transaction transfers the balance from your wallet to the smart contract address. Those funds will be locked for a specific period of time, and pay attention to the data field where we can see the smart contract function ping. After you confirm the transaction, a successful message will appear and the funds are locked. Wait the time interval. So the time interval here is 10 minutes. So you can actually see back in the app how long you have until you can Pong. Let's follow the ping transaction in DevNet Explorer. We sent 1x eGold from our wallet address to the smart contract address. We filled in the data with the ping function name, and now we have the answer OK from the smart contract. Now let's speed up the countdown timer so that we can Pong. After the time interval has been passed, you can claim the funds by clicking the Pong button. Another blockchain transaction will wait to be processed. This time the amount will be 0, as we only have to invoke the Pong function. The transaction will trigger a success message and your funds will be returned to wallet. And that's that. You've created your first Elrond decentralized app. So where do we go next? You can break down this guide and learn more how to extend the smart contracts, the wallet, and the Elrond tools. If you have any questions related to these guides, please feel free to use them using Stack Overflow at the following link. And also share this guide and give it to other people in order to help show how easy it is to actually deploy on the Elrond network and start playing around and create something of your own. Okay, I look forward to seeing what you guys come up with, and if anyone has any questions, please be sure to reach out. Thank you.